So I wanted to prepare this for introduction to antenna tuners for the new ham, and maybe for the old ham. But I wanted to cover three things. What is this antenna tuner thing? What exactly does it do? Why might I want one? And if I did want one, how do I pick one? So three basic questions. And let me start. So first of all, there is a lot of stuff out there about tuners. I nicely called it info, but much of it either not helpful or not true or both. Here's a very simple explanation. The antenna tuner maximizes the transfer of power between your rig and your antenna, both when you're receiving and when you're transmitting. That's actually what it does. And if I had some RF knowledgeable engineer, he would say, of course. So that's the simplest explanation for what it does. There's some more sophisticated explanation of why it does that, but that's not matter here. So how does it do that? So we have to go back a little bit of history. Around the Second World War, coax cables started to become very widely used. Just think about running, ladder line or stuff from a radio room somewhere in the middle of an aircraft carrier up to the radio antenna way up on the mast. Not easy to do. So people started using coax, which I think most of you know is basically a wire inside a metal tube. And in the case of most common coax, it's a wire surrounded by some kind of insulating material and a woven braid on the outside that forms the tube. And there's a characteristic of coax that's something called its characteristic impedance, which for a bunch of reasons actually have some technical merit. They chose that the coax characteristic impedance should be about 50 ohms. And there's a lot of big brains went into this decision. So after the war, a lot of hams started picking up coax because in New York City, you used to be able to go down to Cortlandt Street and there were just, like 30 stores selling it by the reel. And it was really cheap. Even 14-year-old kids could afford to buy some. So the important thing about the 50 ohm thing is that what you would like for the coax to work correctly is that what's attached, whatever's at one end of the coax should look like a 50 ohm resistor, and presumably whatever's on the other end of the coax also looks like some power source in series with a 50 ohm resistor. So the truth is some antennas do behave like a 50 ohm resistor. Now, you might think, why is it a resistor? Well, a resistor is really a thing that takes electrical energy and turns it into heat. An antenna simply turns it into radio waves. But remember, the energy that's going into the antenna ideally is going away from the antenna in terms of your signal. And so most antennas don't behave like 50 ohms. And even the ones that do so over a relatively small frequency range. So there's always a problem of trying to get that power into the antenna when the antenna no longer looks like 50 ohms. Now, this is a little engineering goodie. The maximum power transfer from any electrical source is most effective when the effective resistance of the source equals the effective resistance of the load. That is, you would like your source to look like some kind of electrical generator with a 50 ohm resistor in series. And that will transfer down the coax with minimal loss, and then end up in the load, hopefully, as much of it as possible. but if the load is not 50 ohms resistive, then what you see at the rig end depends on some complex combination of how long the coax is and what the actual load impedance is, which may be it may be resistive, but more likely is also what we call reactive, that it looks like not just a resistor, but a resistor in either a capacitor or inductor. So what an antenna tuner does is that wherever it's connected, it adjusts the impedance coming at the coax end into the other end of the tuner, and at the other end of the tuner, whatever the maybe complicated impedance at the end of the coax looks to the rig like 50 ohms. And it does that, if you like, by magic. I will show you a picture of one at the end. So what's this about both ways? Well, you usually think, well, what you want to do is get as much power from your rig up to the antenna so you get the most signal out on the air. But remember, your antenna is also transferring power back to your rig when you're receiving. It's not very much power, but it is power. And so the better matched your rig is to the coax, the more power, that is, better signal you're going to receive. So the antenna tuner also improves the ability of your rig to hear weak signals. In other words, it helps you both ways. So the first question most people ask is, well, I have this brand new shiny rig and it has an antenna tuner. Why do I need another one? Well, the answer may be you may not. If you have a good antenna, the internal tuner may be all you need, but you most likely don't have an ideal antenna tuner. You don't have an antenna, and the internal tuners in the rigs have a relatively limited range over which they can match. And the reason for that is that to design a tuner that will cover a wide range and fit into a small box just isn't practical. In other words, you really need more space than these little, I'm looking at my 7300 here, have room for. And so because of that, the tuner in your rig is not capable of handling a very wide range of loads. It can handle a modest range, and some antennas, like some of these verticals with all the coils and whatever on them, do provide a reasonable impedance, and that your internal tuner can handle it. But for a much wider range of antennas, you need some kind of external tuner to handle the wider load. And also, another thing, if you have an amplifier after your rig, all the tuner can do is make a perfect match into the input of the amplifier, but the amplifier is now looking at a mismatch. And if there's a lot of power, you really don't want to have a lot of mismatch. It leads to things like melted wires. So, so there are a lot of choices for tuners. You can get a manual one or an automatic one. A manual one is one where you have some knobs and maybe a meter or two, and you turn the knobs according to the instructions, and the meter tells you when you've got a match. You can also get automatic tuners, which do the same thing, except they have a little computer in there that figures out how to adjust all the various parts to handle the broader range matching. Other thing is, you need to worry about how much power do you want the tuner to handle. If you have an amplifier of any significance, you're going to need a fairly big, physically big tuner, because the parts that go into it, the coils and capacitors, have to be pretty big. The capacitors have to have a lot of spacing because sometimes the voltages on them can get quite large. We're talking kilovolts, and the heating losses in the impedances, the inductors in there, can get pretty hot. I had a friend who had his kilowatt amp mistuned, and the first thing he noticed was when the copper tubing coil in his tuner melted. So you really need to have some pretty beefy components to handle the power. And so that bigger components means a bigger box. The manual tuners will require some, practice on your part to learn how to use it, but they're generally a little cheaper. Now, finally, one other thing, where should the tuner be? A lot of these external tuners or manual tuners are basically designed to sit next to your radio, but there's a better place for it, which is right as close to the antenna feed point as possible. And the reason for that is that coax, like any conductor, has some loss, but this loss increases a lot if the load is not 50 ohms. This excess loss can result in maybe 50% or more of your power disappearing as heating up your coax. And so even though the tuner, your rig with the tuner sitting next to it, makes your rig think it's seeing 50 ohms, the fact is that from between the antenna tuner and the antenna, the coax is not carrying its, is not at its ideal thing with 50 ohms at either end. If you put the antenna tuner at the feed point, it will do the same thing. That is, it will take the whatever impedance the antenna is, turn it into, so it will look like 50 ohms to the coax. And so the coax is now working at its optimum, namely it matched to its characteristic impedance. And so you minimize the loss. And again, if you have an amp of any kind, that 50% of a kilowatt is 500 watts, and it will do in your coax pretty carefully. If you go look on the web, you can probably find pictures of people who've show you pictures of badly melted or burned coax. So I happen to have an LDG auto tuner. It's a little box that sits out right next to the feed line coming down from my end-fed antenna, and it gets 12 volts coming down the coax, and whenever I momentarily turn off the 12 volts and then turn it back on, the tuner will then go through a cycle and tune whatever the antenna is to 50 ohms. And so from that point on, my coax is running at as low a loss as possible. Given that I have to string almost 100 feet of coax up through my attic, I really don't want to damage it. Thank you. So let me show you. This is a picture of what one of these automatic tuners look like. What we have here, let's see here, these little boxes are relays, and you can see down the middle here a bunch of coils, inductors, and these big square thingies, and these are capacitors. And the way these work is you have a circuit that kind of looks like that. You have a series of inductors with a relay across each one, and you have a series of capacitors going to ground with a relay across each one. And by opening and closing the relays, if both these are closed, then there's a short to ground. But if you leave these open the way this picture is drawn, the sum of these two capacitors is shunting to the ground. And again, these inductors, because the short is open, these two inductors are in series. And so you have what's called an L network, because it looks like kind of like the letter L. And you can shift these tuners also have a thing where you can basically shift the capacitors from this end of the network to that end, because either one may be needed to do a match. And then there's a little microcomputer here that uses this as an SWR bridge, and it senses the RF and does a switches things in and out in some, according to some algorithm that's hidden in the code, but eventually finds a combination of capacitors, inductors, and whether it's the input end or the output end that give you a perfect match. And it usually can do these pretty quickly. I think my my LDG tuner actually has a memory. And so sometimes if I switch to a different band, I can actually just hit like the dash key on my keyer, and the tuner will instantly switch back to the configuration that is remembered. So these little things are very nice. They're not expensive. And they really do a good job. If you, especially, if you're living in a situation like, say, a high rise in Clearwater, and you can just string some wire across dangled from your balcony, a tuner like this will really give you the ability to at least do some HF work. So that's a kind of place where they're useful. If you're an HOA and you're hiding a wire in the trees, again, that's an antenna that's almost certainly not going to be 50 ohms, and the tuner will turn it into something that's usable. So with that, let me stop. Any questions? Let me stop sharing. Okay. So questions, anybody? Everybody's muted. Dan?
Yeah, you'll have to unmute. You can unmute
Oh.
now. Anyone who's got a question.
How do I tell?
Well, here's Bill Barron here for the moment. Let me ask you this. Have you had good luck with the automatic tuners? I've burned one up.
This is my second LDG. The first one got hit by lightning after a couple of years, and I sent it to LDG asking them to fix it, and they just sent me a new one. So I'm a big fan of LDG, but in general, it works pretty well. I've got a 50-foot end-fed, maybe 15 feet off the ground over to a tree from my house, and it loads up well on 40 through whenever, but on 80 meters, the tuner will tune it, but I get a lot of RF all over the place. So it turns off my computer whenever I hit the key. So not very useful.
Yeah, I found the same thing. It'll tune it, but you're not really putting out any signal in that process. But yeah, on mine, I forgot to read the instructions. If you run 30 watts and run digital all the time, the duty cycle will burn up those LDGs. So I'm pretty careful to run 19 watts now on digital, and I try to watch the time I use it.
Yeah, I run about 25 watts on the FT8 and whatever. With that, it's anyway, those modes are designed not to
Need a lot of power, right?
Yeah, it's considered shouting to do.
Just
Any other
something to,
questions?
yeah, just something to remember. An antenna tuner does not tune an antenna.
No,
It
it's
has
an impedance
nothing
matching
to-
device.
Has nothing to do with tuning an antenna. It's the letting your transceiver load into complex impedance.
Any other questions? Wow, Dave, you did a great job.
Either that
Anybody?
or everybody is stunned. I don't know.
We're so confused. Anybody?
I do have a comment. If you can find a used marine auto tuner, those are designed for a higher service level than most of the amateur products. So if you find a Sea Marine or a Harris 1612, you can find those for $100 or so at Hamfest. Pick one of those up, set it up to automatically tune, and you're good to go.
Nice to know.
Well, I got a question. I haven't used the equipment at TARC yet, but can you just tell us or what antenna tuners are at TARC, and should we use them when we use the equipment?
Well, the antennas at TARC are all, the beam antennas are designed to have basically 50 ohms at some point in the band, and they deviate from 50 ohms enough so that the tuner built into all the rigs can handle, because because you're over a relatively narrow frequency range, and the tuner can handle the deviation from 50 ohms pretty well. We have, I don't think anybody's used it yet. We had donated it's an Orion, is it Orion?
Palstar.
Palstar. It's well, no, the rig is
Oh,
a-
the rig is an Orion, yeah, but the
yeah,
tuner's
it's got a
Palstar.
kilowatt amplifier with two big vacuum tubes in it, and it has an manual antenna tuner with it. I don't know that anybody's ever used it yet.
Dave,
I've
Yeah.
used it. It works fine.
Dave,
Oh,
this
okay.
is Brian. Can you hear me?
Sure.
Yeah, we do have one LDG tuner used for the ICOM 7100, which, by the way, does not have a built-in antenna tuner. So we have one external antenna tuner, and that works fine. You have to push a button, and it's kind of automatic. It'll tune. So just my 2 cents to say we do have one that's outside the rig itself.
Mhm.
You are correct.
And I use the Palstar, and it's very easy to do. Just put the two capacitors at 50 and find your antenna and turn that crank until you see the SWR start going down. Keep cranking, and it'll start going up. Crank it till it goes down, and then you can tweak it using the two capacitors. That's basically how you use it.
Yeah, there are lots of there are lots of designs beyond the simple else match that I sketched out. If you look in the handbook, there are all sorts of configurations of coils and capacitors, some of which are just because somebody got, excited,
Yeah.
some of which there's a common one with two capacitors and an inductor, all variable and arranged in a kind of a T configuration. And
Mhm.
that is somewhat more sophisticated than the L network, but it has a somewhat wider range that it can
Mhm.
match than
Yeah.
a simple L network.
Yeah, the Palstar is a pi network, which is two capacitors and an inductor.
Yeah, capacitor to ground on either side of an inductor.
Right. And our LDG for the 100 is an L network, which is one capacitor, one inductor, and you move the capacitor from the input side of the inductor to the output side of the inductor, depending on what's called a J or minus J, which is a X of L phase, whatever.
Yeah.
I'll leave it at that.
Yeah, what
Hey.
you do is basically don't worry about XLs and all that. You just need to figure out if it doesn't work at one end, switch it to the other end
Correct.
and let the microcomputer do it all for you.
Any other questions?
I should add a historical note that when I was a kid, I had my first radio was a 75 watt CW only crystal controlled radio, and it had a standard, what in those days was a standard vacuum tube kind of output circuit, which was a pi network, the way Lou just described, with two variable capacitors and a coil between them. And one just adjusted those, and that combined, that actually did the match and it adjusted the resonance and did the match all in one thing. So these antenna tuners were not as commonly used back in the vacuum tube days.
Dave, I had a question. You said during the presentation that there was I think you said the best advantage was to have the tuner located at the antenna end of the coax,
Yeah,
and that's like the design of like an AH4 or SGC has one. Uh, Again, I didn't quite understand the advantage of that with regard to where that was located between the end of the coax and the end of the load, where the load is.
Okay, yeah, let me, coax, most coax, has, if you use like RG8, for example, as the frequency goes up, the coax becomes less efficient and you start to, it has some loss. The signal at the output end is not as big as the signal at the input end. But all coax will increase the loss if it's not matched. That is, if you have 50 ohm coax and your load is not 50 ohms, so it's got a high SWR, then the load can increase maybe as much as 3 or 4 dB. Depends on the frequency and the length of the line. So if it's a 3 dB loss, you've lost half your power in the coax.
So basically what you're saying is regardless of the match that you have after the antenna tuner is inserted into the circuit, uh, the coax is still seeing a bad load.
No,
And
the coax isn't seeing a bad load. The tuner, it sits between the end of the coax and the antenna. And so
Right.
what the tuner does is it turns whatever impedance the antenna is into 50 ohms. And so the coax sees 50 ohms, regardless of what the antenna actually is, as long as the tuner is able to tune the antenna. So there's no, it minimizes the losses in the coax itself by ensuring that the coax is seeing 50 ohms at both ends.
Right. I think that was I was trying to get to that simple point that that was why basically the antenna tuner at the end of the load where the antenna is better than at the end of the coax coming down from the antenna.
Yeah.
Is because of that. Okay. I'm a simple guy, and I was trying to work through that in my brain, and it's Monday.
Yeah, I was trying to make it as simple as possible. That just the the more the coax can see 50 ohms, the better off you are.
Got it. Got it.
Anybody else with some questions? It's all good. Lee, you're popped up. You got anything?
No, I would note this. I would note that when you have a coax between the antenna matching system and the antenna, unless that antenna is close to 50 ohms, you're going to have heat generated in the coax. That's not good. You're still putting energy into the system. It's just that you want it to be efficient. That's where putting the antenna tuner or the matching system at the end of the coax where the antenna is the best option. It also keeps RF out of your shack. Ask me how I know this. And finally, yes, if you do have the antenna, the antenna matching unit set up remotely, you are going to have to provide power to it, but you can actually do so through your coax. They make isolators that will dump power onto the coax and then pull it off.
Yeah, you can run both RF and DC voltage down the coax, and then using simple, you can put a capacitor in series and the DC won't go through the capacitor, and the RF basically just goes through without any problem. So you basically have these little boxes that inject power into the coax along with the RF, and then in the tuner itself, there's a way to separate the two. That's what my LDG does.
And I've got the same thing, Dave, and that's the beauty of it, that you can send the 12 volts down there. I'm
Mhm.
doing the same thing. I'm just putting it on a wire that would no way match 50 ohms, but that LDG does a great job. And being automatic, it's easy to use.
Yeah, if you're gutting one of these quote automatic remote tuners and you're trying to put it outside, you have to watch. Some of them, the LDG is nice because all you need to do is put 12 volts to it and it does everything by its own. Some of these have a separate control cable. And so that means you're not only running your coax, you're having to run some kind of extra cable down to the tuner. I think I think the MFJ has a remote tuner, and I think it requires a separate control cable. I'm not, I can't remember every one of these.
All right. Any other comments, questions?
Yeah, I was just going to say, because the antenna tuner that I got, I don't think I can put it outside. So I guess there's some antenna tuners you can put outside by the base of the antenna then?
Yeah, the LDG is in a case and it's sealed, and got gaskets and all that. So I mean, mine have been sitting out in the yard on a basically about a foot off the ground on a little pole. And they've been doing that for 8, 9 years now.
Yeah, and the SGCs you can set up so that every time you change frequency, it'll see the new frequency and retune. So that way you don't have to have control cables.
Yeah, I forgot to mention my LDG and a lot of the remote tuners will automatically tune when they see if you're working, say 20 meters, you go down to 40, the tuner will recognize that you've changed frequency and it will automatically retune. So you can, I have a little box here that actually feeds the DC in, and I have a button on there I push and it just cuts off the DC for a minute. So when it comes back on, the tuner says, I better, and it will just automatically, I can force the retune.
Well, Dave, thank you so much. We appreciate it. Great information. We are recording this, so give Dan a few days to get it edited and put together, and you'll be able to find this for the review or to share with others on our website under videos. So again, thank you, Dave. Appreciate your input tonight and a great presentation.